This is Algebra 2, Lesson 4-6, Completing the Square. Completing a perfect square trinomial allows a person to factor the completed trinomial as the square of a binomial. In other words, you use completing the square when you can't really factor it in any other way. You can solve an equation that contains a perfect square by finding the square roots. It's the simplest type of equation to solve, especially if it's in the form of x squared equals c or ax squared equals c. So let's take a look at the first thing, which would be solving an equation by finding square roots. Let's say we have the following equation. 4x squared minus 25 equals 0. If we want to solve this by finding square roots, we simply want to make sure that anything with the variables on the left side, anything that doesn't have the variables on the right side. So what I'm going to do here is I'm going to add 25 to both sides. So if I add 25, I add 25, I get 4x squared equals 25. Now I need to get x squared by itself, so I'll divide by 4. Now, contrary to popular belief, I'm not going to give this as a decimal because 25/4 doesn't break down to a whole number. If it reduced to a whole number, I would leave it that way, but I'm going to leave it as 25/4. Now, to get x by itself, I simply need to take the square root of x squared, and if I take the square root of one side, I have to take the square root of the other side. Right? Remember, when you take a square root, unless you're told you're just getting the principal square root, it's a plus and a minus. And since we are solving, the square root of x squared is x, and this would equal plus and minus the square root of 25 over the square root of 4. And if you remember, the square root of 25 is 5, and the square root of 4 is 2, so this would be 5 over 2. So x would equal plus or minus the square root of 5 halves. And yes, you have to have the plus and minus because they both would work in this particular equation. Problem number 2 here, 3x squared equals 24. I'm going to do basically the same thing. I'm going to divide by 3. So I'm going to get x squared equals 8. Okay. Now I need to take the square root of both sides. I'll take the square root of this side and the square root of this side, and I will get x equals plus or minus the square root of 8. But now, if you remember, we have to reduce the square root of 8. And we have to reduce it to simplest radical form. If you remember, 8 is 2 times 4, and 4 is 2 times 2, so this would be 2 square roots of 2. Okay. So x will equal plus and minus 2 square roots of 2. Number 3, x squared minus 1/4 equals 0. Again, set it so that the variable's on one side and all the numbers are on the other, so we have x squared equals positive 1/4 because we'll add a fourth to both sides. We have x squared by itself, we'll take the square root. So we have the square root of x squared is x equals plus and minus the square root of 1 over the square root of 4, which means x equals plus or minus the square root of 1 is 1, and the square root of 4 is 2. So x equals plus or minus 1/2. And last but not least, 6x squared minus 486 equals 0. Okay, first thing we need to do, get the 486 on the other side, so 6x squared equals 486 if we add it to both sides. Divide both sides by 6 here, and you're going to get x squared. And in this case, 486 is divisible by 6. It ends up to be 81. Okay? If you can reduce it, you do. In problem number 1, we could reduce to 25/4, but it would have been a decimal. I don't want a decimal answer. I want exact answers, so I want fractional answers. Here, it ends up to be a whole number, so we can reduce it. Now, if we take the square root of both sides, we get x equals plus or minus 9. So, solving by finding square roots is fairly simple. Now, sometimes an equation shows a perfect square trinomial to a constant. Okay? So, to do that, we can solve and factor and do a bunch of other things. I want to make sure I didn't skip a page here. Oh, no, maybe I skipped down here. Yep, I did. I knew I did something. Okay, so sometimes an equation shows a perfect square trinomial equal to a constant number. To solve these, you factor the perfect square trinomial into the square of a binomial, and then you find its square roots. For example, if we have x squared plus 10x plus 25 equals 36, we don't want to move the 25 over because we're still going to have a 10x. If we look at this, we know that this x squared plus 10x plus 25, that's a perfect square trinomial. That ends up to be x plus 5 quantity squared. So the first thing I do is I take that and I factor it to x plus 5 quantity squared. And that equals 36. Right? And we know that we can take the square root of both sides. So if I take the square root of x plus 5 quantity squared, I get x plus 5. If I take the square root of 36, I get plus and minus 6. Now I just need to solve, so I know that x plus 5 equals plus 6 and x plus 5 equals minus 6. So I set it up so that x plus 5 equals 6 and x plus 5 equals negative 6, and then simply solve for x. So you get x equals 1 and x equals negative 11. So let's look at some problems in that respect. Let's say we have x squared minus 14x plus 49 equals 25. We're going to solve this in the same way. So we're going to look at this trinomial right here, and we're going to factor it. It's got to be a perfect square. Okay? 49 is a perfect square. It's 7. So I know this is going to factor to x minus 7 quantity squared. And that's going to equal 25. Because it factors to x minus 7 times x minus 7. So now to solve this, I'm going to take the square root of both sides. I'm going to take the square root of this side, and I'm going to take the square root of this side. So I'm going to get x minus 7 equals plus or minus 5, because the square root of 25 is 5. So now I have two possible answers here. I have x minus 7 equals 5, and I have x minus 7 equals negative 5. And I'm going to solve both of these. So if I add 7, x equals 12. And if I add 7 here, x equals 2. So x can equal 12 or x can equal 2. Problem number 2 here, x squared plus 12x plus 36 equals 9. Okay. Again, I'm going to look here. Square root of 36 is 6. 6 times 6 is 36. 6 plus 6 is 12. So this is a perfect square trinomial. It factors to x plus 6 quantity squared, and that's going to equal 9. If I take the square root of both sides, I'm going to do that in a different color just so you can see a little bit better. I will get x plus 6 equals plus or minus 3, because the square root of 9 is 3. So I now know that x plus 6 equals 3, or x plus 6 equals negative 3. So if I solve this, I get x equals negative 3, and x equals negative 9. So x equals negative 3 and negative 9. Now, if one side of your equation is not a perfect square trinomial, you can convert it into a perfect square trinomial by rewriting the constant term. The process of finding the last term of a perfect square trinomial is called completing the square, because that's what you're trying to do. You're trying to complete the square. Okay? So, you can complete the square of a perfect square trinomial in the form of x squared plus bx by adding b over 2 quantity squared. Okay, so you end up with a formula that looks like this. X squared plus bx plus b over 2 quantity squared equals x plus b over 2 quantity squared. It may seem a little confusing right now, but as we go through a couple of examples, it will make a lot more sense. So let's take a look at something. We're going to complete the square. It says, what values completes the square? In other words, I need to find what number goes here to complete this square. So the first thing I do whenever I do these types of problems is I figure out what b is. b equals 14. And remember, they said you need to take b over 2 and square it and add it to both sides. So b over 2 is going to be 7, and I'm going to square that, and it's going to be 49. So what value completes the square? The value that completes the square is 49. Okay. Here on x squared minus 8x, my b is negative 8. I'll divide that by 2. That gives me negative 4. I'm going to square that. That gives me 16. So the value that will complete the square for this particular problem is 16. So that's the value that would complete the square. Now, if you're actually asked to solve by completing the square, you need to follow the following steps. The first thing you're going to do is rewriting the equation in the form of x squared plus bx plus c. So to do this, get all the terms with the variable on one side of the equation and the constant on the other side of the equation. Divide all the terms of the equation by the coefficient of x squared if the number in front of x squared is not 1. Determine what a, b, and c are. Take half of b and square it. Add it to each side of the equation. Factor your trinomial, and then solve for x. Let's work through a few problems together to make sure you're understanding the process. So we're going to solve by completing the square. Step 1 says you need to get all the numbers that do not have a variable, okay, one side of the equation. So the first thing I need to do here is I need to move my 4 to the other side. So I'm going to add 4 here. So I now have x squared plus 4x equals 4. So I need to figure out the value that goes here, and I'm going to add that same value here, because that's the process. And we've rewritten this in the form of x squared plus bx equals c. The coefficient in front of x squared is 1, so we don't have to divide by anything. So we're going to figure out what a, b, and c are. Okay, in this case, I'm pretty much, a is 1, b is 4. I haven't figured out what c is yet. Well, c is 4 because I moved it to the other side. So I take b is 4, divide it in half, which is 2, square it, which is 4. I need to add this value 4 to both sides of the equation. So I'm essentially doing this. So I now have x squared plus 4x plus 4 equals 4 plus 4. Since I added the exact same value to both sides of the equation, I kept the equation balanced, and it works. It's just fine. So now I just need to solve this. So I have x squared plus 4x plus 4 equals 8. So, complete the square. What's x squared plus 4x plus 4 is x plus 2 quantity squared, and that's going to equal 8. I now need to solve this. I really need to move these numbers. And we're just going to move these problems down a little bit. I'll move the problems down in a minute, because I just need space. So, if I have x squared, x plus 2 quantity squared equals 8, I now need to take the square root of both sides. So that gives me x plus 2 equals plus or minus the square root of 8. If you remember, the square root of 8 is 2 square roots of 2, so I have x plus 2 equals plus or minus 2 square roots of 2. Now to solve for this, I need to solve for x. Okay, so I now have x plus 2 equals 2 square roots of 2, and x plus 2 equals negative 2 square roots of 2. So subtract the 2. Remember, you can only combine like terms. I can't combine the 2 with the 2 square roots of 2 because they're not like terms. So x will equal negative 2 plus 2 square roots of 2. And x equals negative 2 minus 2 square roots of 2. Or to simplify writing this, you could say x equals negative 2 plus or minus 2 square roots of 2. I do not care if you write it separately or together. I have a tendency to write them like this, as together, but you could write them separately. That is just as fine. It works just as well. Okay, let's look at problem number 2. Let me scroll back up here a second. Problem number 2 says x squared minus 2x minus 1 equals 0. We're going to solve by completing the square. So the first thing we have to do is move that negative 1 to the other side. So I'll add 1 to both sides. So I get x squared minus 2x equals 1. Now I have to complete the square. My b term is negative 2. Divided by 2, I get negative 1. Square it, I get 1. So I now have x squared minus 2x plus 1 equals 1 plus 1. So I have to add that term to both sides. X squared minus 2x plus 1 is a perfect square trinomial. I can factor that to x minus 1 quantity squared. And in case you're having trouble factoring these, something you should notice x squared plus 4x plus 4 factored to exactly what it was before you squared it, x plus 2 quantity squared. Notice this factors to x minus 1 quantity squared. It always does that. So I have x minus 1 quantity squared equals 2. Take the square root of both sides. So x minus 1 equals plus or minus the square root of 2. Now I'm going to add 1. So x equals 1 plus or minus the square root of 2. And I have the solution for that one. I can actually leave 4 where it was, but I will have to put 3 someplace else. Okay. All right, let's take a look at number 3. I'm going to scroll way down on my paper here so that I can add 3. Number 3 said, I'll do it in blue so you can see it a little bit easy. Number 3 says 2x squared plus x equals 6. So it is in the form of ax squared plus bx equals c. However, it does have a constant term in front of the x squared that's not 1. So I now need to divide everything by 2. So I basically now have x squared plus 1/2 x equals 3. And I still need to figure out what number completes my square. Okay. So b is 1/2. Okay. B equals 1/2. Divide that by 2. If you remember, dividing by 2 is the same as multiplying by its reciprocal. So basically b is 1/2 times 1/2, which is 1/4. Square that, you get 1/16. So I need to add 1/16 to both sides of my equation. So now I have x squared plus 1/2 x plus 1/16 equals 3 plus 1/16. Yes, you have to deal with fractions. Okay. X squared plus 1/2 x plus 1/16 will factor to x plus, what did I remember what I told you? If you look at it, okay, it's going to factor to whatever you had before you squared it. Okay, so it's going to factor in this case to x plus 1/4 quantity squared. And that's going to equal, okay, 3 plus 1/16, which is 49/16, because this would be 48/16 plus 1/16. And it's a whole lot easier to use it as an improper fraction than it is as a mixed number. Okay, 3 and 1/16, 16 times 3 is 48, plus 1 is 49, so it's 49/16. So now we need to solve this, so take the square root of both sides. So x plus 1/4 equals, plus or minus, the square root of 49 is 7, the square root of 16 is 4. So x will equal negative 1/4 plus or minus 7/4. Okay, which we can actually do. Okay, we can actually figure out the addition for that. So I have negative 1/4 plus 7/4. That equals 6/4, or 3/2. Then I have negative 1/4 minus 7/4, which equals negative 8/4, which is negative 2. So my answers are x equals 3/2 and negative 2. Completing the square, yes, there are fractions, but they're not any more complicated. You just have to be careful with your fractions. So let's look at number 4. 2x squared equals 3x minus 4. First of all, I'm just going to tell you that we're not going to do this problem, because we can't do this problem until after 4-8, because we have to learn complex numbers. So just ignore that problem, just get it out of your notes, and you don't have to worry about it. All right, now, once you can complete the square, you can change a quadratic function into vertex form. Okay, so write it in vertex form. You have y equals x squared plus 6x plus 2. So then you're basically going to complete the square, but you have to keep everything on the same side. It's kind of interesting the way it works. It's just you got to be really careful with how the equation works. A lot of people get lost in the process, but I will walk you through it, and I think you'll be fine. Okay. Remember, before, we didn't have a y in the equation. We just had an equation, and we had to get it in the form of ax squared plus bx equals c. Here, since we have a y, we basically are going to complete the square on the right-hand side of the equation, and everything has to be done on the right-hand side. Remember before when we added the square to both sides of the equation, that kept the equation balanced? So here, what we're going to do is we're going to do something very similar. So here I have my equation. I have x squared minus 10x minus 2. b is negative 10. I'm going to divide that by 2. I'm going to get negative 5. I'm going to square that. I get 25. So before, we added 25 to the left side of the equation and the right side of the equation. We can't do that because we have a y on the left side of the equation. So to avoid that problem, we have y equals x squared minus 10x plus 25, right, minus 2 minus 25. So what we did was we added it to one side, we added it and subtracted it to the equation, which means we basically added 0. Because if you add the same thing and subtract the same thing to an equation, you're adding 0. So by adding it and subtracting it, we've kept the equation balanced, much like we did before when we added it to the left side and added it to the right side. Difference is, now I have this part of my equation here, which I can actually factor because it's negative 2 minus 25 is negative 27. Okay? So now I have it in vertex form. My vertex form of my equation is y equals x minus 5 quantity squared minus 27. And I am done. Okay? There's not solving it, you're just transferring it from standard form to vertex form without having to do the negative b over 2a and all that other stuff. Okay? It's by completing the square. Okay, number 2 here, I'm just going to move it down here so I can see it a little bit better. So 2 says y equals x squared plus 5x plus 3. So b is 5, we divide that by 2, and then we square it, so we're going to get 25/4. So yes, we're going to have to deal with a fraction here. Okay, so now I have y equals x squared plus 5x plus 25/4, because I added it, plus 3 minus 25/4 because I have to subtract it. I add it to the equation and I subtract it from the equation. Okay. So now I can factor this part right here. So y equals, that's going to factor to what it was before we squared it, x plus 5 halves. We know it's plus because there was not a negative sign inside the parentheses. Quantity squared plus, okay, or it might be a minus by the time I'm done. Okay, in this case, this would be 12/4, right? Minus 25/4. I just found a common denominator. I'm showing you what I'm doing. So y equals x plus 5 halves quantity squared minus 13/4. And that's the equation in vertex form using completing the square. Let's do number 3. Number 3, y equals x squared plus 5x plus 2. So my b term is 5. Divide that by 2. Square it. I'm going to get 25/4. So I will have y equals x squared plus 5x plus 25/4 plus 2 minus 25/4, because we add it and subtract it, so we're basically adding 0. Factor the x squared plus 5x plus 25/4 to x plus 5 halves quantity squared. Okay, and then you're going to have 8/4, okay, plus 8/4 minus 25/4, because all I'm doing is taking this and simplifying it. 25 minus 8 is 17, so x plus 5 halves quantity squared minus 17/4, and of course I have to put my y equals because I forgot that. So y equals x plus 5 halves quantity squared minus 17/4. You will find that if you can complete the square, you'll make your life a whole lot easier because you'll do an awful lot of completing the square to solve other types of problems in not only this class, but also pre-calculus and also calculus. So this is a lesson on completing the square.